involving artistry and machinery, old world methods, and 21st century technology.
That's what they do here at the Bureau of Engraving and Printing, where hundreds of people come together to literally make money.
Today, we're at the Bureau's Washington, D.C. facility to see how they make the new and improved $20 bill. Since 1996, the agency has been redesigning almost every bill in order to stay one step ahead of counterfeiters. And every redesign starts with a new drawing.
So you drew the eagle?
Literally, we would hand draw this eagle.
Once artists complete the drawing, a team of engravers transfers it onto a stainless steel plate. In the case of the $20 bill, engravers worked for 2 dashes and lines into the steel. The result? A one-of-a-kind master die that's nearly impossible to duplicate, even by computers. Every single $20 bill in circulation has come off this die. After engravers complete the die, they pass it off to a siderographer, the person who transfers the steel plate to plastic. The plastic replica will become the printing plate. First, he covers the steel design with a sheet of plastic less than 1 millimeter thick. Then he sandwiches the two pieces between aluminum plates and bakes them for 6 to 8 minutes in this oven.
There it is.
There it is, $20 bill.
A plastic $20 bill.
The siderographer then makes 32 more plastic impressions and welds them together on one large sheet. This way, the Bureau can print 32 bills at one time. Workers coat these sheets in chromium, inspect them, and finally secure them to the printing presses. Now they're ready to imprint their images onto paper. But the Bureau of Engraving and Printing can't use just any old paper to make money. At Crane & Company in Dalton, Massachusetts, they make a special kind of paper that's nearly impossible to duplicate.
Is this where the paper starts? Where we're standing right now is the staging area. That's the beginning part of the process.
Most paper is made from wood, but banknote paper is actually made from fabric. It's a special blend of 75% cotton and 25% linen. The fibers of these materials are naturally stronger than the fibers in wood. That's why the paper doesn't tear as easily and has the distinctive crisp feeling of money. The first step is to get all this cotton into that contraption.
What is that? Well, that's the vessel that we wash the fibers in.
It's called a rotary boiler. Inside, steam pressurizes the vessel, which cooks 3 tons of cotton in a caustic mixture of sodium hydroxide and other chemicals. This brew strips the fibers of any waxes or other impurities to help the fibers bond together. This makes the paper stronger. After this 2-hour spin cycle, it's time to open the boiler's lid.
It's not going to come out in a giant wave that washes this all away or anything, is it?
No, it just kind of falls out.
The stuff coming out is now purified cotton. Then a loader transports steaming piles of the cotton to this conveyor belt, which drops it down into a machine called the pulper. It's basically a 5,000-gallon underground blender. Water rinses away any caustic chemicals still present in the fibers, while blades chop the cotton into shorter pieces. From here, massive machines drain, strain, tear, bleach, squeeze, press, and finally cut the cotton into clean 4x4-foot sheets. It might look like the paper is ready to go, but it's not. These sheets are only made up of cotton. Remember, they still need to add linen to create the final blend on which U.S. currency is printed. So workers must load both the cotton and the linen into yet another pulper.
All of those sheets get
dumped into this a tank with thousands of gallons of water, and at the bottom is an immense grinder that just rips them back into pulp. If you were to ever fall in here, you would be instantly disintegrated.
After a thorough mixing, the slurry ends up behind these doors. We can't film what's next because this is where they add the 3 security features that make U.S. currency so tough to counterfeit. First, a machine randomly incorporates red and blue fibers into the paper while it's still a slurry. The fibers are clearly visible when you look closely at a bill. Next, another machine adds a watermark, a faint image that matches the engraved portrait on the bill. And finally, a machine adds a security thread 1.5 millimeters wide. This plastic thread denotes the value of the bill and cannot be detected by the reflected light of scanners or photocopiers, making it nearly impossible to duplicate. Now that the people at Crane & Company have finished making their special paper, we've come back to Washington, D.C. to see the rest of the money-making process.
So we're finally printing some money. What does this machine do?
This is the newest division of the Bureau. We're putting the offset color background on the $20 bill here today.
Remember how U.S. currency used to look? Every bill was the same, black and green. In 2003, the Bureau introduced additional layers of color as another anti-counterfeiting feature. The $20 bill received background colors of green, peach, and blue, a large blue eagle on the front, and small yellow numerals on the back. And since time is money, this first printing step goes really fast. Once offset printing is completed, the bills go through a quality control check at this machine, the Auto Smart Scanner.
So here's the final product of the offset process.
This is where we're going to check the quality attributes of the offset printing and also the densities or the amount of ink that we're putting on the sheet.
And it's completely robotic.
It's completely computerized.
So what is it looking for exactly?
It's going to be looking at the color bar. It's going to be looking at the different colors of ink, all of them on the one side, and comparing it to the program, and it takes all of about 10 seconds.
Okay. And what if you notice something that needs to be adjusted? What happens?
They'll go over to the console and they'll make color adjustments for the particular ink that they have to make adjustment to.
So from that console, they control the whole press process?
That's correct. That's
okay.
correct. The console is wired to both sides of the press, all the ink fountains.
Very cool. You do it with a robot?
So the scanner records the thickness of each color applied to the sheet. If the layers do not match the quality parameters set by the Bureau, the inspector will make the color corrections on the spot.
And where does this piece of paper go once you finish the offset process?
Once we've finished the offset process, it'll dry for 72 hours, and then it'll go on to the intaglio portion.
Okay.
Now the bills go through a second round of printing. Each step adds to the complexity of the design and the security features. These are the intaglio printers that give the bills their signature look. These presses contain the chromium-coated plates with impressions of the $20 bill. But this is only one side of the bills. After the printed backsides dry for 72 hours, it's time to print the front of the bills. But unlike the backs, workers print the faces with 2 black inks and a color-shifting ink called optical variant ink. This special ink can be seen on the number 20 in the lower right corner of the bill. When you tilt the bill up and down, this ink causes the color to shift from copper to green. It's yet another way the Bureau of Engraving and Printing stays one step ahead of counterfeiters. So this is money. Almost. The paper still has to be tested to make sure the banknotes will hold up to the real world. And that happens at the Durability Lab. Here, Workers put samples of paper through the wringer. They're thrown into the laundry, crushed in a crumple machine, and doused with chemicals that attempt to remove the ink. Once the paper gets the lab seal of approval, it's time for the government to put on its own seal of approval. Workers feed the now 16-note sheets into this, the third and final printing press, the over-printing machine. This press gives the bills their last three components: the green Treasury seal, black Federal Reserve seal, and serial numbers. But these sheets won't exactly fit in a wallet. The government must still cut them down to size. Stacks of 100 sheets pass through two very sharp guillotine cutters. The first slices the sheets horizontally. The second makes the vertical cut. All that's left now is counting the cash. 100 individual bills make a strap. 10 straps make a bundle. And 4 bundles make a brick. These cash bricks wait in a massive vault for delivery to the Federal Reserve banks and eventually the general public. By the way, the average life expectancy of a $20 bill? About 2 years. But don't worry, the government will always print more.